Welcome to part 2 of classifying angles. Now, the last video we talked about how to classify them based off of what their measures are and if they were complementary, supplementary, or their vertical angles, alternate interior angles, and alternate exterior angles. Now, that's only the first part. There's also a lot more of how we can classify these angles as. Now, we can classify them by what they measure as. So, as you might have heard this from middle school or elementary school, we have acute angles, right angles, obtuse angles, straight angles, and reflex angles. So, our first one is acute angles. Now, acute angles are angles that are smaller than 90 degrees. So the measure of the angle is less than 90 degrees. Now let's say that an example would just be like this, where the angle itself measures 53 degrees. That is also an acute angle. So from the range of anything larger than 0 to anything smaller than 90 would just be an acute angle. Now, for our second type of angle, we have right angles. Right angles, on the other hand, they're always going to be fixed at a certain degree, and the way how we signify this is by drawing this thing right here. It looks like a square, a box, right? It just means that it's 90 degrees. The measure is 90 degrees. Right? So now, if we really think about this in multiple lines, right? If we have two perpendicular lines like this, right? Let's see, this is just perpendicular lines, right? So segments A, C, and B, D, right? So we can say that line AC is perpendicular to BD, right? Line AC is perpendicular to line BD. Now, this symbol right here that we just use means that they are perpendicular. Perpendicular, right? And just because it's perpendicular, we have right angles. Because perpendicular lines always, always, always form right angles in this case. Now, the next angle type that we have is indeed obtuse angles. Obtuse angles. Now, these angles are larger than 90 degrees, but they're smaller than 180 degrees. So an obtuse angle can look like this. Do that. Like that. Let's say this is 157 degrees. So the angle would be larger than 90 degrees. That's the angle. And also smaller than 180 degrees. Then, second to last, we have straight angles, right? Straight angles. Now, straight angles, on the other hand, is just 180 degrees. Just like how we had the right angle as 90 degrees, the straight angle is 180 degrees. So it would just be one line right there. And of course, the angle is 180 degrees here. Right. And lastly, we have our reflex angles. Now our reflex angles is any angle measuring over 180 degrees. So it could be something like this, where the way how we measure it is from the outside. So it could be like 234 degrees right here, right? It's anything that's larger than 180. So that's why we call it a reflex angle. Now, by understanding all of these, right, let's give you some examples, right? Some practice examples. Now, take a moment and do this by yourselves. Pause the video, right? And check these out. Classify these angles for me. And 6, we're gonna put 170 degrees. So take a moment, classify these angles, and we'll get back to reviewing what they are. Hopefully you just took a moment by yourself and classified these these angles. Now we can figure out what they are. So the first one we have is 15 degrees, right? Now 15 degrees, it's larger than 0, but also smaller than 90. So we can say that it's an acute angle. Now the next one we have is 235 degrees. That's larger than 180, so it has to be a reflex angle. Now 50 degrees here, it's also smaller than 90, so we can say that it's an acute angle. 180 degrees, it's dead on 180, so we can say it's a straight angle. Now 90 degrees, also a similar rule, we can say it's a right angle. And lastly, we got 170 degrees, which is smaller than 180, but also larger than 9 degrees, so we can say that it's an obtuse angle. Now, it wasn't that hard to figure all of that out. And there's one thing that we've missed from the last video, which was angle bisectors. Now, angle bisectors, we use that in proofs a lot because many of the problems they state that, oh, okay, so this angle bisects that angle, right? Well, this angle is bisected by this line segment that we have there. So let's draw it out and see if we can approach an example with it. So angle bisectors. Let's say we have this angle right here. It looks like a 90 degree, right? And we have an angle bisector right there. So let's say A, C, and then B, D. Now, let's say it says that angle BAD is bisected by ray AC. Right? So what does that really mean? Because if we break down the word bisected, right, or bisector, if we break down the word bisector, we see bi. Bi in mathematics usually means two, right? So you can have bicycle, right? That's also two because two wheels, right? Cycle is also wheel. And in this case, it is bi. So that means that our definition for this is that the angle is split in two congruent parts actually. Now, what if it was a line bisector? What if it was a segment bisector? Well, it would mean the same thing. The segment is divided into two equal parts. But Just because it's aligned, we have a special case with it because of the way that it's being said, right? So we're going to get to the line portion in a bit. We will just first focus on the angles, right? So now, since angle BAD, right? Let me highlight this out for you. Angle BAD, right? Since angle BAD is equal to 9 degrees, since angle BAD equals 90 degrees, we can say that since ray AC is bisecting angle BAD, we can say that BAD is split into two equal parts. And two equal parts would just mean 45 degrees on each of them. So that means that angle BAC, which is leading up to the angle bisector, is 45 degrees, and angle CAD is also 45 degrees because it's split in two. All right. So now, what if we have this as an example? What if we had this as an example? So let's do this. We're gonna put it J as well. No, wait. Let's do 5x plus 10. And then let's draw this here. Let's say that this is 2x plus 15. Right? Now, we're gonna put some letters here. A, B, C, D, E. Okay, so let's say that angle DBC is bisected by ray B, and that angle ABC equals 180 degrees. Now take a moment and see if you can find what x equals. Find x. Pause this video here and see if you can find what x is equal to by understanding what an angle bisector necessarily means. Alright, hopefully you guys just pause the video here there and figured out what x equals to. So since we know that angle DBC, right, DBC is being bisected by B, right, is being bisected by this line. So that means that the whole point of it is that this 2x plus 15 is also the angle for this, right? Because it's being bisected, so it has two concurrent angles. So that means that the whole entire system that we have here, right? Angle ABD is equal to 5x plus 10. Angle DBC, well, DBE is equal to 2x plus 15. And last but not least, angle BEC is also equal to 2x plus 15. So now all of these would equal to 180 degrees, right? Because angle ABC is 180 degrees. So these are all supplementary pairs, well, supplementary angles all combined together, right? So 5x plus 10 plus your 2x plus 15 plus another 2x plus 15 equals 180 degrees. Now, when you add all the like terms, you get 9x plus, we got 10 plus 15 plus 15 equals 40 equals 180 degrees. Subtract that 40, 9x equals 140, and x would equal to, let's see, 140 divided by 9, that'll be 15.56, right? Just round that up. That is what we get for our angle, well, for our x. Now, in the beginning, I said something about how the language might differ, right? So, if we say that in terms of lines, right? In terms of lines, let's say that line AB is bisected by line CD, right? So now we have line AB, and it's being bisected by line CD, right? C. Now, it doesn't necessarily mean that line CD is being split in two, but it necessarily just means that line AB is split in two. So we use the two tick marks there to signify that those two are equal segments, right? Now, when would it be a case where CD is split in two? Now, it would be a case when it says that line CD is being bisected by line AB. That would be the case if CD was being split up in two, right? Unless they say, oh, line AB is, they could also say that the line AB is the bisector, right? Or line CD is the one being bisected, right? But it's all comes down to like which one's first and which one's the last one. So you have to really look for the wording there, because sometimes they're gonna give you problems that are a little bit confusing, right? But you still have to, make it happen that way. Now, there's some common mistakes that people make with these problems, and an angle bisector just splits the angle in two. It doesn't necessarily make it supplementary or complementary, but it just splits it in two. And unless you're trying to find the whole entire angle, right? Like the big angle, you're not gonna add them up together. So if they're only asking you for one of the angles, don't add them up together unless you're putting them equal to a certain value that you already know. If they tell you to find a larger angle, then definitely put it together. But I hope that clears up some things about angle bisectors, especially with these topics. And I hope to see you guys next time. Remember, always practice your geometry.